Hi everyone, I've been asked to show my system to you, and first, before I show it, I'd like to start it with showing my workbench, because this is where the system is born. And if you are on your audio journey and you want to get into tweaking stuff, modifying, building, doing your own designs, then this is where I would say this is a key component to what you are doing, and it will make your life very different if you have an organized workbench. So when I started, I was just doing things on, not on the kitchen table. I don't recommend soldering on the kitchen table, but like on the patio. I had a table set up there, and my first tool that I got for my audio journey. Let's get some more lights here. You see, I have extra lights, and I can just put it somewhere else to get some more light on here. Bingo. So the first tool I want to show you is the solder station. So if you want to buy one, I would recommend first to just surf online. That's what I did when I bought mine. That was about 20 years ago. And what I can tell you from my experience and what people experience in general is that you don't want to play around with the cheap solder irons, just getting a pencil or a digital toy. Those are not heavy duty, and they will make your life quite miserable on the long run. And when you switch over to a solder station, then that will just drastically change the quality of your soldering. That's what happened to me as well. I started with a Radio Shack iron, and I thought it was good, and well, it did its job, but going to the Hakko was a night and day experience. So for the solder station, the Hakko, this is a 60-watt station, but it's as good as, or I would say as strong, as powerful as I would say a 100-watt Radio Shack station. Charlie bought a 100-watt Radio Shack station when I bought this 60-watt Hakko, and I compared the two of them, and actually this heats up faster and has more heat transfer capability than that 100-watt station. And so the Hakko, they still make solder stations, but the new ones look a little bit different. I think that's yellow and blue color scheme, and it looks a little bit more round than this, but it's the same thing in a new housing. Here, that's the iron. So Hakko has several iron for its stations, and this I got the medium size iron, and because they have small, medium, and large. The small sizes are good if you work on circuit boards, fine soldering. It's okay, but if you want to do like solder like thicker wire or work on tube amplifiers or solid state, no matter what amps, then the fine iron will not be big enough to handle the bigger soldering duties. And you can change the tip. So I choose the medium iron because you can go for really small tips to big tips for it. So that's just perfect. And when you work with it, I do not recommend using a sponge. It's really ineffective, doesn't clean well, and if you wet it, well, it cleans a little bit better, but it's not really good for your tip to cool it down so rapidly, and it still doesn't clean well. So what I've been using for over a decade now, or maybe almost 2 decades, is steel wool. So this is really fine steel shavings. You can get this at the stores, at City Mill or Home Depot. It's called steel wool, and you can just wipe it, and then it wipes it super duper clean and very fast. So I love it, and it lasts extremely long. So I just changed this steel wool. The previous one I've been using for maybe, I think, years, several years. And also, just a quick word on the lifespan of your solder stations. So these guys are not just wonderful to work with, but they last a really long time. For example, the tip I'm using here, let's just show, maybe here you can see. Can you see? No, you cannot really see. I'm using a flat tip. This is, I think, a 4mm flat tip. Because if you use tips for point-to-point wiring, you want to use bigger tips. If you just use like really tiny pieces, work on tiny resistors, tying them to tiny wire, then you are okay with the usual fine point tips, which heat up faster, but it doesn't matter. This station heats up everything around the same time. That's not an issue. But what I want to say is that you want to have like a bigger surface area to have to be capable to heat up the surfaces you are working with. And these tips will last basically forever. I'm on my second tip that I've been using for 20 years, and I'm on my second tip because the first tip that I used, actually that one, maybe this is my third tip, I'm sorry. So this is the third tip I'm using. The first tip, I basically killed it within a month because I left the station on for about 3-4 days. So I didn't switch it off. I thought it was off, and then I was going about with my things and noticed that it's on. And after being on for about 4 days, first of all, my house didn't catch fire, yay. And second, the station survived, the iron survived, and the tip survived 2/3 of the way. Its tip got pitted, so about 1/3 of its surface area became unusable, and the solder did not stick to it anymore. So I changed that tip to a new one, and I've been using that second tip for 15 years. Always made sure that the station was turned off when I'm not using it. And then that tip lasted for 15 years. And I still have that tip in my drawer. It's still usable, but I just decided, okay, I just start to use another one. So basically that's it. I've bought a bunch of tips when I bought it. Here they are. And most of them are still unused. I never needed to use them. I'm using the small tip to use with finer work, and I tried out a couple other ones, but I didn't need to use them really. So all you need is 2 tips, one really fine point, a round point for delicate work, and the big one like a 4mm flat tip or a bevel tip. I've been using that bevel tip for 15 years. So I would say that's the most important part of your arsenal to get a great solder station. And as you see, the Hakko has been my companion for 20 years. And early on I started, and eventually during these 20 years I've been using it to work with silver solder. And they have a much higher melting point than regular eutectic solder. As you see, it's set to 460 degrees Celsius, so it's burning hot, steaming hot, and with that hot temperature the tip lasted for 15 years. and I give them really serious heavy use, thousands of hours literally. And these are my solder I'm using. Just a couple examples. I have plain resin core and I use it for desoldering. So this is when you have some device and you want to remove an existing joint, then you have to suck the solder up. And for that, use a solder sucker. You can push it down and then put it to the wire, and then it sucks up the solder after you heat it up. First, of course, you have to heat up the joint and then you can suck up the solder. So for that I use the regular rosin core because it has a much lower melting temperature, so it makes desoldering easier. But for actual soldering, these two are my main go-to wires. For this guy, you cannot really see much of the inscription. What was the catalog number or name for the solder? But this is a 4% silver solder. There's no lead in it, and it's a thicker solder. And I have this other one, a caster solder, and this one has is also no lead in it, and has 3.5% silver in it, and it also has 0.5% of copper in it. So it's similar to what AudioNote is doing. AudioNote solder is 6% silver and 2% copper, and they add antimony to lower the soldering temperature. But basically they are doing something like this solder does, but they upped the silver content. But by adding antimony, they decrease the melting temperature of the solder. But you have to know that when you decrease the melting temperature, you're also making the solder, I would say, the conductivity worse. But I think when you have that 6% silver, that really wins over conductivity in overall. But I have to add that I have not tried yet the AudioNote solder, because you can buy it in like really big spools, like a 500-gram piece of solder costing $350. So I'm thinking about getting one, but it's really expensive. However, these two are my bread and butter solders, but as you see, this one is really thin compared to that. So I use these two to work on gear, on amplifiers, cables, whatnot. But if you want to work on circuit boards, I really don't recommend to start with these, because once you solder something onto a PCB with silver solder, if you want to undo it, you will curse. You will have a field day about learning new curse words, expressions, because it's a nightmare to remove high melting temperature solder from a circuit board. But just to use this, because this is a thin solder, so if you happen to have thin solders, you will be very disappointed because they do not work well, because you have to keep on unwinding a lot of these wire to have enough solder to melt onto your connection point. So what I do with it is that I get a couple rounds and then I twist them together. So you see, now we can get a thicker solder, just like that one there, if you can see that. So that's how you can use it. If you have like a good quality solder but it's too skinny to use, then you can just double it up, quadruple or octuple it up and then you can use that. And this is my really good solder. It's AudioQuest solder, and AudioQuest does not reveal its content, but they say there's more silver in it than lead. So yes, this has some lead in it, And the point for that is that actually lead makes for a really good solder joint. That's why they use lead in the first place, but they do not use it nowadays because it's toxic and you don't want to smell the fumes. So that's why I put my station next to the lanai so that I have ventilation here and I don't have to inhale the fumes. So this solder, this has the best bass ever. So it sounds just like these two guys, but better bass. And I've also tried out lots of different solder types. Like for example, when I started out, I started using the WBT solder and Carlson solders. WBT gave like a, I would say, kind of like a too much like a showy sound. I didn't really like it. It wasn't my taste. Carlson solders, I was really disappointed with them. They barely sounded anything better than the Rosencore of the Radio Shack with some extra colorations. And then I started using the Caster lead-free high silver content solder, and actually I tried out many different kinds. If you have 3.5% silver or 4% silver, then you'll have a very good wire. I mean, connection made by the good sounding musical, natural sounding joints. And this thing, it just adds a lot of bass, but it costs a lot as well, and it's not really easy to get these guys. So what I'm doing usually is that I'm making the joints with these guys, and I put a dab of this in addition. And when you do that, you can see that this flows so much better than those solders, because it has a lower melting point and has lead in it, so it will make for a much nicer looking joint. This will make also a super nice looking joint, the Rosencore solder. The silver solders, if you have like high content silver, like 4%, they will make really ugly joints. They will look like a dead solder joint. And yes, that's correct. If it was a silver-free solder, then it would be a dead joint, a dull-looking joint. But with these guys, no, it will not be a dead joint. It's a working joint. It just doesn't look as nice as a regular joint. This guy, it makes for nice-looking joints as well. But all that matters is really sound and stability. And to work with this solder, the high percent silver, it's not easy. So if you are a beginner, I would recommend to try some eutectic solder, some Rosencore that doesn't have high silver in it, so that you can work with something that has a melting temperature about around 400 degrees Celsius or lower. And when you are good with that, then go into the high silver content joints, because I can tell you that there's a lot of people who have been soldering their entire life, and when they try to switch over to work with these, they failed. And I know not just one person, but many. So I will show you how to work with high silver solder. And as I say, do not worry that by using the high temperature you burn up your iron, because my iron lasted for 15 years and I'm using it a lot. So I want to show a little bit more of my workbench, my work area. And I have to say it was inspired by Mr. Carlson's lab. If you know that YouTube channel, he has a most amazing looking workbench. So I designed and built a table and also the shelves. And as you see, I have my scope here, and then the shelf is designed that way that it can house the scope. And then here the shelf doesn't come out that much, so I can like put an amplifier here upright and work on it, and I have space for that. And here, this is a really critical component, that is a variac. It's been my companion for 20 years, and I will tell about what a variac does of course signal generator. I have 3 multimeters. In the beginning, if you start out, it's enough if you have one, and just get a good fluke meter. They like this is like older than 20 years, many years. So they just last forever. And one is that you want in the beginning, but if you are working with amplifiers that use like 600-700 volts supply, in that range, then you must have several meters, because you cannot hook up the meters where you are testing the amp. How you work on 700 volts is you first hook up the meters to the points you want to test, and then you turn it on, because you don't want to electrocute yourself, because with 700 volts it is dangerous. So I've been working with 400-500 volts all my life from the beginning. I mean from for 20 years, and 500 volts is really peanuts compared to 700 volts. I've been shocked many times by 500 volts. It's not a walk in the park, but I dread to see the day if I was ever shocked by 700. It's an entirely different ballpark with severe consequences. So what else do I want to say? So also on the workbench I have, you see, 2 flat panel speakers mounted here, so that if I'm testing an amplifier or working on an amp, I can hook up the test speakers to it and check out what's going on, so I don't need to blow up my main speakers if there's something wrong. I am using these guys, and of course the variac is needed to heat up slowly an amplifier to see if it draws too much current. You can catch it before your fuse goes or your power transformer or something else goes. You need the oscilloscope when you are troubleshooting. Here the scope is here and the signal generator is here. We use them together. So the signal generator generates a test signal that you feed to your amp or preamp or phono stage, whatnot, and then you can use the scope, put the probe to whichever test point you want to test, and then see if the signal comes through clean or what sort of noises there are. So that's what I use to troubleshoot for amps that have issues or amps that work, but I want to see how they work and what I can improve on them. So I also have a few additional tools. I'm not going to show everything, but for example, this is a capacitance meter, so you can measure the capacitances, because the fluke meter and that meter too, that measures capacitance as well, but only up to 20 microfarads, and above that it doesn't measure capacitance. So then the other one measures to half a farad. So always to have tools, it's a good idea. Have more tools than you think you need, because you're going to use them all. And for example, here you want to have something to cut wire that is of high quality. This is my absolute favorite wire cutter. It's an insanely good tool, and it's indestructible. These guys, in comparison, they are still high quality, and you see they are really ancient, but they are not as strong and do not cut as clean. What else? So you see I have 2 magnetic bars. These are from IKEA to put tools on them, and I have another one there, and also like these guys, I have some tubes to play around with, small tubes, additional tools up there for fine working, and parts, and that set of drawers that's from IKEA too, that's also for parts. And as you see, my working area, it's in my living room, it's in the corner, and that's that's the sweet spot for you. And I have two chairs on the side, records in the back, and if we flip around, there I have the projector, Blu-ray, and other side facing it, that's where the system lives. So I did this deliberately so that if I'm working on something, I can still listen to music, and I think this is well, this is what I wanted, and this is what I did. So let's just go back here, and that's for today. Thank you for tuning in.